Hey guys, so today we are starting section 6-5, which is linear and nonlinear functions. And so most of this will be a review. You should hopefully remember from somewhere back in your memory. Some things we've done more recently, so it'll be more familiar. But we're just going to go through the examples on page 266 and 267. I'm actually going to do all the odd problems for you. And then later in the week when you work in the textbook, you'll do the even problems. So you can use this as a guide. So you need to take notes in your math journal. You need to write down everything that I'm writing. And the first thing is notes. So start copying, and I'm going to briefly explain it, but then when we do the problems, it'll make more sense. So a function is when each x value is paired with exactly one y value. In other words, the x values do not repeat. So when you have a set of ordered pairs, I'm just going to write it in this chart because it's much easier to look at. But say I have these ordered pairs. Okay, so there's my ordered pairs, and I put it in an XY table so it's easier to look at. What I am looking for is that my x's do not repeat. If my x's repeat, it is not a function. But if my x's do not repeat, then it is a function. So the domain, just as a reminder, are all your x values, and the range are all your y values. So copy this down, and I will be right back. All right, so starting with the odd numbers in the book, on page 266, number 1, it's giving us an XY table, and it says, is this a function or not? So remember, I'm looking to see if my x's repeat. If my x's repeat, it is not a function. So I'm just going to look at my x values. Do any of those repeat? Yes. The ones repeat. So it is not a function. All right, for number 3, I'm going to do the pencil test. So remember we did the pencil test last year where you take your pencil and you hold it vertical on the graph and you run it along the side of your graph to see if any points touch each other on the same line. So if more than one point is on this line that you're running across your graph, it is not a function. That means the x's are repeating. So I think I can show you with my ruler tool. Okay, so if I use my ruler like we used our pencil last year and I run it along the graph, immediately as soon as I get to the graph, I already have 2 points touching the ruler. So that means it is not a function because these points are repeating all over this graph, okay? You can see how when I'm right here, I actually have 4 points that are touching the ruler at one time. So that is not a function, okay? All right, and for number 5, the easiest way to do this is to make an XY table. I'm going to pick some values for x, whatever values you want. You know, usually I take a couple negative, I'll put 0 in, and I'll do a couple positives. So I can graph my line and see if it's a function. So let's do -2, -1, 0, 1, and 2. And I'm just going to plug in that number for x and then solve and see what y equals. So for example, for the first one, I'll do y equals -2 squared plus 1. So -2 squared is 4. 4 plus 1 is 5. So when I put -2 in for x, y is 5. Okay, and I'll do the same thing with each of those numbers. Just plug it in for x and see what y equals. So when I plug in -1, I'm going to get 2. When I plug in 0, I get 1. When I plug in +1, I also get 2. And when I plug in a +2, I also get 5. So let's graph this and see what it looks like. I'm going to erase this equation. because it's going to get in the way of our graph. All right, so -2, I'm going to run out of room on this graph. I think I better go like halfway in between each line. Okay, so -2 and +5 is going to be here. -1 and +2. 0 and 1. 1 and 2. 2 and 5. Okay, so there's all my points plotted. Now I'm going to connect those. This is going to be a parabola. Now I'm going to do my ruler test again, or your pencil test, and I'm going to see if when I pass this ruler over my graph, does more than one point at a time touch the ruler. So let's see. And the way this graph is shaped, only one point at a time touches the ruler. So this is a function, yes. Okay, so that one took a little more work because we had to graph it, but now we know it's a function. So copy this down and I'll be right back. All right, so on this section, it says graph each function for the given domain. So remember, domain is your x values. So they gave us all the x values and they want us to plug those in to see what the y's equal and then graph it. So I'm just gonna start solving with the first number. And remember, when two things are written next to each other, it means multiply. That's why I used parentheses there. So -4 times -2 equals a +8 minus 1, and 8 minus 1 is 7. So there's my first ordered pair, -2 and 7. I'm just going to keep going. Y equals -4 times -1 minus 1. So that's 4 minus 1, which is 3. And then plug 0 in. It's easy to see if you were to plug 0 in, it would just be -1, because that x and the -4 would go away. So let's keep going. -4 times +1 minus 1. So now we got -4 minus 1, which is -5. Caleb's playing a game with his friends, so I don't know if you can hear him in the background, but that's what that is. And then -4 times 2 minus 1, which would be -8 minus 1, which would be -9. Yes, okay. So now I'm just going to plot each of these points and graph it, and that's all it wants me to do. Graph it for the given domain. So then we'll be done after we graph it. So again, these are my ordered pairs. So now I'm just graphing each ordered pair and connecting the dots. So I got -2 and +7, which is way up here. I have -1 and +3, 0 and -1, 1 and -5, and then I have 2 and -9. So here's 2 and 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, that fit on my screen. That was lucky. So I'm going to try to connect those dots the best that I can. It is a straight line. So let's see if I can do it. Hey, I did it. Okay. And then you would put little arrows on the end because it's a line that goes on forever in both directions. And that's it. That's all we had to do for that one, is figure out the y values and then graph it. Okay? All right, just a reminder, you're supposed to be copying all of these in your math journal. So if you're not pausing and taking this down, go back and do it. It's important, okay? So The next problem, again, it's the same thing. Graph each function for the given domain. So the domain on this one is all real numbers. So let's look at the equation and figure out what that means. I have f at x equals -3. Now, if you will remember from what we did last year, f at x is another way of saying y. Okay, so my equation is basically y equals -3. When y equals -3, that means my point is on the y-axis at -3. So let's put a point there. And my line is going right through that point horizontally. Okay, so that is the graph of y equals -3. And that's it. We didn't have to plug anything in for this one because it's all real numbers, which means any number that we choose. All right, so y equals -3 looks like that. And that was an easy one. I skipped 11 and 13 because, again, that's just a pencil test. You're going to take your pencil on the graph and drag it across. And if more than one point touches your pencil at any time, it is not a function. So number 11, not a function because it's a circle. Number 13 is a function because if I drag my pencil across, only one part of that line at a time will touch my pencil. Okay, so let's look at this last section. It says graph each function. So again, in order to graph it, I have to make the XY table, and I need to pick values for X. And I'm telling you, I always pick the same ones. Unless it doesn't help, then I have to go back and do different ones. But those are my go-to numbers for X. Okay, so you just pick whatever numbers you want. And then you're going to plug in and solve the equation to see what, whoa, my thing wasn't counting for a second. Totally threw me off. Okay, so you're going to plug each number in, see what the y value equals, and then we're going to graph it. So I'm going to pause while I do all these equations because I'm running out of time on my video. So you work it out. I'll work it out. We'll come back, see if you got the same answers as me. Okay, so there we go. I solved all those x values to see what y would equal. I put all those y's in my chart, and now I'm just going to graph each one. So -2, +3, -1 and 0, 0 and -1, 1 and 0, and then 2 and 3. So again, we have a parabola, and we know that all parabolas are functions because when they're facing up or down, because they do not, the x values do not repeat. The y values do, but the x values do not. So it is a function, okay? Okay, this is the last one I'm going to do because I'm running out of time. So again, same thing. We're going to make an XY table. We're going to pick values for x. I pick the same ones every time. We're going to plug them in for x and see what y equals. So I'm going to do that, and I'll be right back. Okay, so I had to make some adjustments on the numbers that I chose because you cannot take the square root of a negative number. It doesn't work. It's called no solution. So when I try to take the square root of -2 and -1, it won't work, so I can't use those numbers. That tells me that on this graph, it's all positive numbers for x, okay? And starting at 0 because 0 did work. So my first point's going to be at 0, 0. So then what I did for the rest of my numbers is I picked something that I knew I could take the square root of easily, okay? So I know that 4 is a perfect square and 9 is a perfect square. So that's the numbers that I chose on my x value so that it would work with this equation. So let's just graph the rest of those. 1 and 1. 4 and 2, and then 9, which I'm not going to be able to get to, and 3. So I know the graph is going to kind of go off in that direction. So I'm going to connect my dots, kind of going off in that direction. Okay. So when you guys do these on your own, I will definitely be there to support you and help you in any way. So just let me know if you have any questions. Make sure you copy all this down, and I will see you next time. Bye.